Hi guys, I believe all of you are doing great, having a good time. So let me know in the chats if I am perfectly audible, visible to each and every single student. Everyone means everyone. I know I am 5 to 6 minutes late. Hi guys, I believe. Okay. So in the today's session, we will have to complete rest of the kinematics that we will be doing over here. That is for sure. Okay. Okay. So guys, in the last session, we discussed we say equations of motion. So we'll have to continue the equations of motion today. So I will be deriving these and then we will move on to, we say the graphs. Then we will move on to the graphs. Okay. Like we have got the position time graph. We have got the velocity time graph. Okay. So call up your friends, each and every single student, so that we can start our particular session over here. Okay, good evening, good evening, good evening. I hope everything is audible, visible to each and every single student. I hope everything is audible and visible to each and every single student. So guys, in the last session, we basically discussed the first equation of motion, and that is what we call the we say V is equal to U plus AT. I hope you remember this particular equation. I hope you remember this particular equation. That is V is equal to U plus AT. Guys, see. I told you, let's suppose a car is starting from this particular position. Okay. Initially, it is having the velocity U. And we say after some time, if the car reached this particular position, sure, it takes the time from, we say, sir, 0 to t seconds. Here time t is equal to 0 and here time t is equal to t. What is the velocity of the car finally? That is what we were supposed to discuss in this particular case. Okay. Okay. So my dear friends, this velocity was v is equal to u plus a into t. U is the initial velocity with which it was moving initially. A is the acceleration, and we say acceleration in this journey is constant. Okay. And t is the time. T is the time after time t. This was the velocity of the car after time t. If you remember the last class, we discussed this. Now, guys, in the today's session, we will have to first talk about, we said displacement after time t. That is displacement after time t. Guys, see, listen to me very carefully. We say, let's suppose there is a car which started from this point. Okay. And its initial velocity is, let's suppose, u. There is a car which started from this point and its initial velocity is u. We say after some time, let's suppose the car reached this particular position. I am asking you. We say this much is the displacement of the car covered in this duration. We say initially it is moving with velocity v, u, and initially let's suppose time is 0, and when the car reached over here, we say time is t. T is equal to t. And my dear friends, let me just tell you. We say if somebody asks you what is the value of this displacement, how much displacement the car has done in this time, if acceleration of the car is, we say, sir, constant, if it is moving with a constant acceleration, we are supposed to find the displacement. In the previous equation, we had to find the velocity. But right now, we are supposed to find the displacement. Okay. Yes. So guys, we say, I use the equation as we say V is equal to U plus A into T. We use this particular equation, V is equal to U plus A into T. Okay. Now guys, in this particular case, this is the velocity of the car after time t. Can I write this v as, I say this is ds divided by dt. I'll write this velocity as ds by dt. And I can say over here, this is u plus acceleration into time. I want you to multiply this over here. So we say this will be ds is equal to u plus a into t and u plus a into t, and we write over here this is dt. Now guys, in this particular case, I say integrate both the sides. Integrate both the sides. Okay. Integrate both the sides. If you do the integration on both the sides, what will you write? You say, sir, it is integration of ds is equal to integration of u plus a into t. Okay. And then you say dt. Now guys, you have to basically use the limits. We say, let's suppose initially here displacement was 0 and after time t displacement is s. So we say it is from 0 to s. And initially let's suppose time was 0 and we say finally we say time is t. Now what is this ds? Integration of ds, it will give you the total displacement s. Is equal to, guys, see, now limits are from, we say, sir, 0 to s. Now what is this? Sir, what is the integration of u? We say this is integration of u dt. So take u is constant, take this u out. So we say it is integration of d dt. This and this will cancel, so it will come out to be ut. So integration of u is simply that is u into t. Okay. Then we say plus. What is the integration of at, my dear friends? Guys, see. Integration of a is, guys, I'll write over here, integration of a into t, and this is dt. Acceleration is constant. We know in this particular case, acceleration is constant. Take acceleration out. Then it is integration of t dt. Can I write it something like this? A, integration of t is t square divided by 2. So same I'll write over here a, and then we say t square divided by 2. T square divided by 2. And if we put the limits over here, limits are from 0 to t. And I can say over here, this is s is equal to, we say initial velocity into time plus, and this is 1 by 2, s is equal to ut plus 1 by 2 at square. So this is what we call the second equation of the motion. This is what we call the second equation of the motion. And this gives us, we say this equation gives us the displacement after time t. Displacement after time t. This gives us the displacement after time t. Okay. Tell me guys in the chats, is this crystalline clear till over here? Is this clear till over here? Is this clear till over here, guys? So this is the second equation of motion. Guys, if you have not liked this session yet, like it as soon as possible. Okay. So this is the displacement of the car after time t. Okay. Now, my dear friends, let's talk about the velocity after covering the displacement x. Guys, see. Let's suppose I have got a car over here. This is the car, okay? And this car is moving with a velocity u. And we say after some time, the car has, let's suppose, reached this particular point, okay? My dear friends, in this duration, let's suppose the car has covered the displacement, we say, let's suppose s. From here to here, the car has covered the displacement s. I am asking you, after covering the displacement s, what is the final velocity of the car? These are the two different questions. Guys, if I say after time t, what is the displacement of the car? That is question number 1. Next question is, after a displacement S, what is the velocity of the car? And that is what we call the displacement. We say to find the velocity after displacement, we say, sir, S over here. Okay, guys, see, if I say this car started from this point, sir, after time t, the car reached over here. What is the velocity of the car after time t? That we already got. V is equal to u plus a into t. If I say this car started from this point, it has covered the displacement S. What is the displacement of the car what is the velocity of the car after displacement S? These are the two different questions, guys. See. In this particular case, I would want you guys to use, we say, use A is equal to V dV divided by ds. This is the equation that we have studied. This is the acceleration versus, we say, displacement relation, A and S relation. Guys, see, in this particular case, I want you to multiply this A over here. So this A into ds will give you, that is V into dV exactly over here. Now guys, in this particular case, I want you to integrate both the sides. Integrate, we say, both sides. If you integrate both the sides over here, what will you get? Guys, I'll write integration of, this is A ds, and then we say is equal to integration of V dV. Now the question in this particular case is, what is the initial velocity? Initially it is velocity is u. So when velocity is u, we say, what is the displacement at that point of time, sir? 0. Here displacement is 0. And here displacement is what? S. So car has covered the displacement S. What is the final velocity? That is V. What is the final displacement, sir? That is S. When initial velocity is u, displacement is 0. Here it is integration ADS. Here you have to put the limits in terms of displacement from 0 to S, from u to V. Now guys, take this A out. Why, sir? Because A is constant. This is the case when acceleration is constant. I can write over here, then it is acceleration, then it is A, we say ds from 0 to S. And here I can write, sir, integration of V. So that I'll write directly over here. This is V square divided by 2. Because here integration of V with respect to dV, that is V square by 2 from, we say, u to V, from u to V. And here this and this will cancel. So it is A into S. So can I say in this particular case, this will be A into S here. And here it will be what? That is V square. See guys, this is V square by 2. First you put here in this V upper limit, then minus lower limit. So it will be V square minus u square divided by 2. Because we put first upper limit, then we put the lower limit. Okay. Now multiply over here. So this will be 2as is equal to V square minus u square. So I can write over here V square is equal to u square plus 2as. Now guys, this is the final velocity. This is the final velocity after displacement S. This is the final velocity of the car after covering the displacement S. This is the final velocity of the car after covering the displacement S. Okay. So we say this is the velocity of the car after displacement S. And we use this equation also only when acceleration is constant. Next, displacement in nth second. This is very important. Displacement in nth second. I want you guys to understand very carefully. See guys. Let's suppose I have got a car over here. Okay, I have got a car over here. Okay. And this car basically is moving something like this, This car is moving, let's suppose, something like this. Okay. My dear friends, listen to me very carefully. If I say after t is equal to n seconds, the car has reached this particular position. Sir, what is this n? N can be anything, 10, 15, 20. So we say after n seconds, the car is over here. Okay, yes, yes, yes. Now guys, listen to me very carefully. Can I say, sir, if this is t is equal to n seconds, can I say, sir, this will be, if this is, guys, if this is n seconds, before n seconds, what will be the time? N minus 1. If I say n is equal to 10 seconds, what is the second last second? You say, sir, 10 seconds, and before that will be 9 seconds. If it is n seconds, can I say it will be n minus 1 seconds? This will be n minus 1 seconds. T is equal to n minus 1 seconds. Yes. Now, guys, in this particular case, I want you guys to understand one thing. What is that? You have to tell me this displacement in the nth second. This is displacement in the nth second. That is what is the equation. You guys are supposed to tell me what is the displacement in nth second. I am not telling you to tell me the displacement in the nth seconds. No, 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 no. In nth second. See guys, it is like, let's suppose you started from this point and you reached this point. This is after 1 second you are here, after 2 seconds you are here, after 3 seconds you are here. I'm saying how much is the displacement in 3 seconds? You say, sir, this much is the displacement in 3 seconds. How much is the displacement in 2 seconds? This much is the displacement in 2 seconds. How much is the displacement in first second? You say, sir, this is the displacement in first second. This is the displacement in second, and this is the displacement in third second. So we say this is the displacement in S in third second, in the last second. Same over here. This is what we call the displacement in nth second. This is what we call the displacement in nth second. Okay. Okay. Yes. This is the displacement in nth second. We have to find this displacement in nth second. Guys, see, how do we find it? Let's do one thing. First, we will find the displacement in, we say n seconds. Let's first find the displacement in n seconds. Let's first find, guys, we say we'll first find the displacement from here to here. This is, sir, displacement in n seconds. Okay. How do we find it? Put the value of, with the help of this particular equation, with the help of this equation, S is equal to ut plus 1 by 2 at square. Here, instead of t, we will put t is equal to n seconds and we'll get the displacement. Yes, we'll get the displacement. Same in this particular case, we'll get this. Then once we get it, then after this, we'll find the displacement in n minus 1 seconds. Then we'll find the displacement in n minus 1 second. This is displacement in n minus 1 seconds. This is displacement in n minus 1 second. Now, once you get the whole displacement, then you will subtract this, you will get the value of this. Guys, if let's suppose this is 20 and this is, let's suppose, 18. So 18 minus 20, that will be 2. So you'll get this displacement, that is 2. So what we'll do in this particular case, we say displacement in nth second is equal to, I say displacement in, we say n seconds minus displacement in n minus 1 seconds. This is the logic that I'll use over here. Tell me, is this crystalline clear? Is this crystalline clear? Everybody out there, is this crystalline clear? Is this crystalline clear? Tell me, guys. In the chats, everyone means everyone. Okay. Now guys, further we can write it something like this. See, further we can write it something like this. Sir, S nth is equal to, guys, displacement in n seconds. Guys, see, displacement in n seconds. How can we write it? Sir, use ut plus 1 by 2 at square. Sir, u, instead of t, I'll write over here n. ut plus 1 by 2. Let's suppose acceleration is a. T square. So that is n square. Un plus 1 by 2 an square is the displacement in n seconds. Is the displacement in n seconds. Then we say minus displacement in n minus 1 seconds. You say, sir, ut. Here I say t. What is the value of t? That is n minus 1. That is n minus 1. Okay. Then we say plus 1 by 2 a t square. That is once again n minus 1 whole square. Okay. And once you solve it, open this a minus b whole square. Here also, once you solve this, final answer in this particular case will come out to be, that is u plus a by 2. Then we say 2n minus 1. 2n minus 1. I would want you guys to keep this in your mind. I would want you guys to keep this in your mind. This one. U plus a by 2. U plus a by 2 into 2n minus 1. U is the initial velocity with which it left over here. Okay. And then a is the acceleration over here. And acceleration in this particular journey is constant. Okay. Then 2n minus 1. N is the nth second over here. Is this crystalline clear? Please tell me in the chats. Please tell me in the chats. Okay. So this is basically the displacement in n seconds. Nth second. Now let's talk about the average velocity. Average velocity when acceleration is constant. Guys, see, I would want you guys to focus exactly over here. See, average velocity when acceleration is constant. See, guys, when it comes to the average velocity, we say, sir, it is total displacement upon total time. Average velocity is total displacement upon total time. Can I just write over here, sir? This, what is total displacement? Sir, S is equal to, we say ut plus 1 by 2, we say at square. And divided by, we say time t. Instead of displacement, I am writing this, time is t over here. We say this t and this square will get cancelled out. So we say average velocity in this case will be u plus 1 by 2 a into t. Now guys, tell me one thing. Have you ever heard about this? We say we say v is equal to u plus a into t. Okay, v is equal to u plus a into t. Now, can I just write over here v minus u is equal to a into t? Yes, v minus u is equal to a into t. Now, I want you, instead of this at, put this v minus u. You can write, sir, v average over here will be simply, that is u plus 1 by 2. Instead of at, I can write v minus u. Now, guys, multiply this over here. So you can write this v average simply, that is, this is 2u, then we say plus v, then minus u, then we say divided by 2. Tell me one thing, 2u minus u will be how much? That is u. So v average in this particular case will be simply, that is u plus v divided by 2. So my dear friends, if acceleration is constant, always remember, if acceleration is constant, in that case, initial velocity is given, final velocity is given. You can find the average velocity directly. So we say use this only when acceleration is constant. When acceleration is constant. Even one more thing I would want you guys to focus over here. Sir, what is that? See. We say now, displacement. Can I write, sir, displacement is, we say average velocity into time. Yes. Displacement is average velocity into time. Now, average velocity we know. So I can write, sir, displacement will be, instead of average velocity, u plus v divided by 2 into, we say, sir, time t. Put this also in a box. Put this also in a box. Put this also in a box. So this is the displacement. That is u plus v divided by 2 into t, that is time. And on the same concept, let me show you the question over here. Now see, look at the question, guys. A particle moves in a straight line with a constant acceleration. There is a particle. There is a particle. There is a particle. It is moving in a straight line with a constant acceleration. Okay. So we say acceleration here is constant. Acceleration here is constant. It changes its velocity from 10 to 20 meter per second. So here its velocity is 10 meter per second. Okay. We say it changes its velocity from, we say, 10 to 20 meter per second. We say finally its velocity becomes 20 meter per second. Initially it is 10, finally it is 20. While passing a distance of 135 meters. So it has, we say, passed a distance of, we say, 135 meters. The value of t is, you guys are supposed to find the time in this particular case. Guys, tell me one thing. Tell me one thing. Tell me one thing. Tell me one thing. Look at this. Sir, displacement is equal to u plus v by 2 into t. Displacement is equal to u plus v by 2 into t. I'll take it over here. Now, I can write, sir, displacement is equal to u plus v by 2 into t. What is the value of displacement over here? That is 135. This is 135 is equal. What is the value of initial velocity? That is 10 plus. What is the value of final velocity? That is we say, sir, 20 divided by, we say 2, and then we say into, we say, sir, t over here. Okay. Okay. Now, my dear friends, so this will be, can I just write over here? This will be 135 is equal to 30 by 2. So this will come out to be 15 t. Now this is 135 divided by, I say, 15. So it will come out to be, we say, t. Okay. Guys, is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. I'll be taking the regular classes. That is not a problem. You guys tell me, is this clear? Is this clear? Please tell me in the chats. Everyone means everyone. Okay. Yeah. I'll be taking the regular classes. Not a problem. Chill. Okay. So time here will come out to be 15, 135. So it will come out to be 9 seconds. So time is 9 seconds over here. Great. Next, we have got this question over here. We have got this question over here. Guys, see. The initial velocity of a particle moving along x-axis is u, and its acceleration is given as ax. There is a particle which is moving. Let's suppose this is the particle which is moving along x-axis. Okay. And its acceleration is given as k times of x. Its acceleration is given as k times of x. Which of the following equation is correct between velocity and position? Which of the following equation is correct between velocity and position? Which of the following equation is correct between velocity and position? Now guys, see. We say, here, you can clearly say this acceleration is not constant. If acceleration is not constant, you cannot use the equation v is equal to u plus at, s is equal to ut plus 1 by 2 at square. Or we say v square minus u square is equal to as. You cannot use those equations. Those can be only used when acceleration is constant. So here acceleration is variable. Acceleration depends upon x. Now guys, see in this particular case, what will we do? We say as in this particular case, we say a is equal to v dv divided by dx. We'll use this equation. Okay. Now, multiply this over here. We say, sir, a dx is equal to v dv. Now integrate both the sides. We'll integrate. Hey, see. In this particular case, instead of this a, I'll put the value of acceleration, that is k times of x. So I'll write over here, this is k times of x and this is dx is equal to, we say, integration of, we say, v dv. Now, we say initially, displacement is 0. From 0 to x, I'll put the limits. And here, initial velocity is u, final velocity is v. So from u to v. So here I'll write from 0 to x, here I'll write from u to v. Now guys, understand one thing very carefully. What is that? See, I say, take this k out. If I take this, why? Because k is constant. So I say take this k out, then integration of x will be x square by 2. And then over here, what is integration of v with respect to dv? That is v square divided by 2. And it is from u to v. Okay. Now guys, understand one thing over here. This is kx square by 2. I'll write it over here. This is kx square divided by 2 is equal to. And we say this is, guys, first you put the upper limit, then you put the lower limit. So v square minus u square divided by 2. Then we'll write over here v square minus u square divided by 2. 2 and 2 will cancel. So we say this is v square minus u square is equal to kx square. So we'll write v square is equal, take it over there, u square plus, here it is minus, if you take it from the other side it becomes plus. So then it is kx square. Now match with the options. V square is equal to u square plus kx square. So option C is correct. So in this particular case, we say option C is correct. Next, we have got this particular question. Guys, is this particular question clear? See, the acceleration of a particle is increasing linearly with time as bt. They are saying that acceleration is given as bt. There is a particle, its acceleration is bt. And this acceleration is variable. It is not constant. This acceleration is variable, it is not constant. Okay, this acceleration is variable, it is not constant. Okay, guys. Guys, hit the like button if you have not liked the session yet. I would want you guys to hit the like button as soon as possible. Now, we say acceleration is given as b into t. The particle starts from the origin with the initial velocity v naught. Like it is saying that we have got a particle over here. This particle starts with the initial velocity v naught. And it is moving in this path, let's suppose. And its acceleration is given as b into t. The displacement traveled by the particle is, we are supposed to find the displacement traveled by the particle. It's a very good question. It's a very good question. Okay. Now, guys, here, in this particular question, we can say acceleration is not constant. If acceleration is not constant, do you think that I can use this equation s is equal to ut plus 1 by 2 at square to find the displacement? No. No, sir. No. Why? Because acceleration is not constant. Acceleration is variable. So if acceleration is variable, I would want you guys to focus over here. We say as we say v is equal to, as we say a is equal to dv divided by dt. A is equal to dv divided by dt in this particular case. Okay. Now, guys, tell me one thing, or I'll write this particular equation directly over here. We say as acceleration is given as b into t. Can you write the value of acceleration as? We say, sir, this is dv divided by dt is equal to, we say, sir, b into t. Because we know acceleration is dv divided by dt. Now multiply this dt over here. So it will be dv is equal to, we say, bt, and then we write over here dt. Now integrate both the sides. If we do integration, now put the limits. Sir, limits are from, initially its velocity is v naught. Finally, let's suppose its velocity is v. So we say it is v naught and it is v. Initially time is 0 and finally let's suppose time is t. Now, guys, tell me what is the integration of dv? Sir, integration of dv is v and it is v naught to, we say, v is equal to. Now, what is the integration of bt? B is constant, take it out. So we can say t square by 2. So it is b, and integration of t will be, that is t square divided by 2. And limits are from, we say, sir, 0 to t. So it will be 0 to t only. Now, can I just write over here, this is v minus v naught is equal to bt square divided by 2. Now take it over there. So v is equal to v naught plus, here it is minus, over there it will become plus. Then it becomes b t square divided by 2. bt square divided by 2. Okay, this is the velocity. But what we are supposed to find out, sir? Displacement. So can I write this as, can I write this velocity as? I can write this velocity as, this is ds divided by dt. And I'll write over here, see, this is v naught. So I'll write over here, this is v naught plus b t square divided by 2. Now multiply this dt over here. So I can say this is ds is equal to, we say v naught plus, then we say b t square divided by 2 multiplied by, we say, dt. Okay. Now integrate both the sides. Now integrate both sides. So we say this is integration of ds is equal to, we say, integration of v naught plus, we say, bt square divided by 2 into, we say, sir, dt, Now can I write in this particular case, sir, what is the integration of ds? It will give us the total displacement, that is s. Okay. It is not hard. You guys focus over here. Just there are 3 to 4 bit more calculations. So we say this is s is equal to integration of v naught with respect to dt. Guys, see. If I say it is integration of v naught with respect to dt, what will you do? Take this v naught out, integration of dt. This and this will cancel, so it will be v naught into t. Just put over here. So it will be v naught into t. This is the integration. Then we say plus integration of bt square by 2. I'll write over here. Integration of bt square divided by 2 and dt. Now here b by 2 will come out because they are constants. It is distance, one and the same thing over here. If I'm finding displacement distance over here, it is a straight line. It's a straight line. So it's one and the same thing. So I can say this is b by 2 integration of t square and this is dt. Now guys, so this is b by 2. Integration of t square will be how much? That is t cube by 3. Now 3 into 2 is 6, so it will be bt cube divided by 6. So integration of this will be bt cube divided by 6. So this is basically the distance traveled over here by the car, bt cube divided by 6. bt cube v naught into t plus bt cube divided by 6. Guys, is this clear? Please tell me in the chats. Is this clear? And if you have not liked this session yet, I would want you guys to hit the like button as soon as possible. Everyone means everyone. Is this crystalline clear? Is this crystalline clear? Yes. Next. An important topic now we need to discuss in this particular case. An important topic we need to discuss now in this particular case. Ratio of total displacements in 1 second, 2 seconds, this. Guys, see. Let's suppose we have got a car. This is the car over here. Or this is an object. And it started from rest. Initial velocity is 0. Okay. And the car is moving something like this. Something like this. Something like this. Something like this. This is car is moving something like this. Okay. And car has finally reached this particular position. Car has reached finally this particular position. Okay. Can I say in this particular case, my dear friends, we say after 1 second the car is over here. We say after 2 seconds the car is here. I can say after 3 seconds the car is here. I can say after 4 seconds the car is here. And after 5 seconds the car is here. Yes. Now guys, tell me one thing. I would want you guys to give me the clear answer in this particular case. Crystal and clear answer in this particular case. Okay. Can I say, sir, this is the displacement traveled by the car in 1 second? Yes, sir. Can I say, sir, this is the displacement traveled by the car in 2 seconds? Yes. Can I say, this is the displacement traveled by the car in 3 seconds? Yes. Can I say, this is the displacement traveled by the car in 4 seconds? Yes. Can I say, this is the displacement traveled by the car in 5 seconds? Yes. Okay. So this much is the displacement traveled by the car in 1 second. This is in 2 seconds. This is in 3 seconds. This much in 4 seconds. And this much in, we say, sir, 5 seconds. Okay. Guys, understand very carefully. Understand very carefully. I would want you guys to understand over here. Can you tell me how much is this displacement if the acceleration is a? We say, sir, this displacement will be s is equal to ut, initial velocity is 0, plus 1 by 2 at square. Guys, see, s is equal to, initial velocity is 0, so it will be 0, 1 by 2, acceleration. And time here is how much? 1 second, so it will be 1 square. So it will be simply that is a by 2. Let's call it x. Let's call it x. Now, can you tell me how much is the displacement in 2 seconds? So you'll say s is equal to ut plus 1 by 2 at square. Initial velocity is 0. Acceleration is constant. So 1 by 2 a t square. T is, we say, sir, 2 square. So can I say that will be 2 square is 4. That is 4a divided by 2. Guys, see, what is a by 2? A by 2 is x. So I can say this is 4x. So I am saying that if this displacement is x, so this will be 4x. Let's find this displacement in 3 seconds. You say, sir, s is equal to 1 by 2 a t square. T is 3 square. 3 square is 9. So it will be 9a divided by 2. So we say a by 2 is x, that is 9x. So can I not say in this particular case this is 9x? Absolutely, yes, I can say this is 9x. I can say this is 9x. Okay. And similarly, my dear friends, in this particular case, if this is 9x, how much is this? This is 16x. And this is 25x. Okay, because 4 square is 16, 5 square is 25. Then next one will be 36x and so on. So remember, my dear friends, in this particular case, I can say, guys, see, a car started from rest and acceleration is constant. This is also the condition. We say in 1 second it covers as displacement, in 2 seconds 4x, in 3 seconds 9x, in 4 seconds 16x, in 5 seconds it will cover 25x and so on. Can I say, we say ratio of displacements. I said displacement in 1 seconds is to, we have to find the ratio, is to displacement in 2 seconds is to displacement in 3 seconds is to displacement in 4 seconds is to displacement in 5 seconds. Can I say this ratio will be, it will be x is to 4x is to 9x is to 16x is to 25x. This will be the ratio in this particular case. Yes, 110%. Now, my dear friends, can I say, sir, we can say this is 1 is to 4 is to 9 is to 16 is to 25 and so on. This is basically the ratio that we have in this particular case. That's what we call the ratio of total displacements in 1 second, 2 seconds, 3 seconds, so on. X is to 4x, 9x, 16, 24. Next we have ratio of displacements in first second, ratio of displacement in first second, second second, third second, fourth second. Guys, see, let's suppose the car started from this point. Let's suppose the car started from this point. Okay. And we say its initial velocity is 0. Initial velocity is 0. And the car is moving something like this. Car is moving something like this. Okay. Car is moving something like this. And finally, the car has reached this particular position. Guys, let's suppose in this particular case, after 1 second, the car is over here. We say after 2 seconds, the car is here. After 3 seconds, the car is here. After 4 seconds, the car is here. And 5 seconds, the car is here. Tell me one thing. Guys, can I say, sir, this is the displacement of the car in first second. Can I say, this is the displacement of the car in second second. Car has covered this much of displacement. Can I say this is the displacement of the car in third second? Yes. Can I say this is the displacement of the car in fourth second? Can I say this is the displacement of the car in fifth second? Yes. Guys, displacement in first second, displacement in second second, displacement in third second, displacement in fourth second, displacement in fifth second. And what is this one? Displacement in 1 second, 2 seconds, 3 seconds. This is basically the complete displacement. And this much is displacement in 1 second, 2 second, second, third second, fourth second, fifth second, and so on. Guys, see. Can you tell me what is the displacement in first second? That is x. Can you tell me what is the displacement in second second? That is this much displacement. You say, sir, total is 4x minus this x. 4x minus x, you will be getting this as 3x. Similarly, displacement in this third second. Total is 9x minus 4x. This will be 5x. So I can directly write over here. If this is x, we say this is 3x. We say this is 5x. We say this is 7x, and we say this is 9x, and so on. So we say, guys, displacement, we say, I'll write over here, displacement in first second. Then we say is to displacement in second. Then we say is to displacement in third second. Is to, we say, displacement in fourth second. Okay. Then we say is to displacement in fifth second. It will be, that is x is to 3x is to 5x is to 7x is to, we say, sir, 9x. So this is the ratio that we have exactly over here. X is to 3x is to 5x is to 7x is to 9x. I can write it 1 is to 3 is to 5 is to 7 is to 9. Guys, is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. And most importantly, guys, hit the like button, everybody of you. If you have not liked this session yet. Now, let's take a look exactly at this particular question. This was the question which was asked in NEET 2017. What will be the ratio of distances moved by a freely falling body from rest in fourth and fifth second? Guys, see, if there is an object which is freely falling over here, always remember, whenever we release an object, its initial velocity is 0 and its acceleration is constant. Always remember, I'll teach you this also, but as of now, you remember, it's, we say, initial velocity is 0, acceleration is constant. So means the condition is will satisfy. This condition will only satisfy if acceleration in this case is constant and initial velocity is 0. Now ratio, we say in the first second is x, ratio in the second is 3x, ratio in the third second is 5x, 7x, 9x, and so on. Okay. Now guys, tell me in the chats over here, what is the answer of this particular question? We say, guys, in fourth and fifth second it is asking. We say, sir, displacement in first second is to displacement in second is to, we say, displacement in third second is to displacement in fourth second is to displacement in fifth second. So it will be simply, that is x is to 3x is to 5x is to 7x, okay, and is to 9x. Now in fourth and fifth they are asking. In fourth second it has covered 7x, in fifth second it has covered 9x. So we say s fourth upon s fifth will be 7x divided by 9x, x and x will cancel, so it is 7 by 9. It is 7 by 9. It is 7 by 9. Okay, that is 7 by 9. Which option is correct? This option is correct. Next we have got, in the same category, a body starts from rest. What is the ratio of distance traveled by the body during fourth and third second? During fourth and third second. Sir, in the fourth second it will cover 7x, in the third second it will cover, we say, 5x. So we say s fourth divided by s third will be 7x divided by 5x. Okay, this and this will cancel, so it will be 7 by 5. Option A. Option A. Option A. Okay. Next we have got this question. Next we have got this question. Next we have got this question. A body starts from rest. What is the ratio of distance traveled by the body during fourth and third second? During fourth and third second. Sir, in the fourth second it will cover 7x, in the third second it will cover 5x. So we say s fourth divided by s third will be 7x divided by 5x. Okay, this and this will cancel, so it will be 7 by 5. Option A. Option A. Option A. Next we have got this question. A stone falls freely under gravity. It covers the distance h1, h2 and h3 in the first 5 seconds, next 5 seconds and next 5 seconds. We have released a stone over here. Okay. So let's suppose the stone falls something like this. Stone falls something like this. Stone falls something like this. Okay. My dear friends, let's suppose in the first 5 seconds, listen to me very carefully. In the first 5 seconds, it has reached over here. And in the next 5 seconds, we say, sir, that is means this is 10 second over here. It has reached over here. And in the next 5 seconds means 15 seconds, it has reached over here. And it says that in the first 5 seconds, the height is h1, then it is covered h2, and then it has covered, we say, h3. Okay, initial velocity is 0 over here. Now in this particular case, I'm showing, if it is not visible, I'm showing over here. A stone falls, we say in the first 5 seconds, it has covered h1 height. In the second 5 seconds means at the 10th second, it has covered h2. In the 15th second, it has covered h3. Now guys, see, in this particular case, you guys are supposed to tell me what is the ratio, the relation between h1, h2 and h3. Guys, see, it is exactly like the case ratio of displacement in first second. Here, instead of first second, you have given first 5 seconds. I'll write it something like this. Ratio of displacement in first second is to ratio of displacement in second second is to ratio of displacement in third second. It is x is to 3x is to, we say, sir, 5x. Now, instead of first second, here you have given first 5 seconds. We can also write it something like this. First 5 seconds is to, we say, displacement in second 5 seconds. Sir, what does that mean? That means first 5 seconds means this interval. Second 5 seconds means this interval. Third 5 seconds means this interval. Okay. So we say I say displacement in, we say, third 5 second. So it is given as, we say, h1, we say is to, we say this is given as, I'll write over here, this is x is to 3x is to 5x, so on. But this is given as h1 is to, we say, h2 is to, we say, sir, h3. The ratio is given something like this. In first 5 seconds, it covers h1. Either you say in first second or first 5 seconds, even first 10 seconds, then the next interval should be also for next 10 seconds. So it is given as, we say, x is to 3x is to 5x. Now here, can I say in this particular case, h1 divided by h2 will be simply, that is x by 3x. This and this will cancel. Take it over there. So h1 will come out to be h2 divided by 3. Call this as equation first. Now, from this ratio also, can I say h1 by h3? What is the value of h1 by h3? h1 divided by h3 will be simply. That is x by 5x. This and this will cancel. Take it over there. h1 will come out to be h3 by 5. Now, this is the second equation. Guys, see. First equation, h1 is equal to h2 by 3. In the second equation, h1 is equal to h3 by 5. Now, don't you think we can compare this? So I can write from first and second equation, h1 is equal to h2 by 3, which is equal to h3 by 5. So now let me show you which option is correct over here. h1 is equal to h2 by 3 is equal to h3 by 5. That is option 3. That is option 2. Okay. Now this is the question which I'll give you as homework. Guys, I would want you guys to put up the answer of this particular question in the chats. I would want all of you to put the answer of this particular question in the chats. And if you have not liked this session yet, I would want you guys to like this session as soon as possible, because liking this session is extremely mandatory, guys. Now. Let me just tell you something which is extremely important right now. Sir, what is that? That is, guys, recently we have launched the Phoenix Pro batch, okay? And in this Phoenix Pro batch, we'll be teaching you each and every single thing from the scratch. And it is only for, right now, its price is only, we say, 4,999 rupees, okay? I want you guys to buy it as soon as possible, okay? So join it, because it is for NEET 2025. Every single thing will be taught, and its classes are starting from, we say, 31st July onwards, okay? So I don't want you guys to miss out any of the live classes out there. So in day after tomorrow, its first live class will be there, okay? So join it as soon as possible, guys. Join it as soon as possible, because definitely you are going to love the content that we will give in this particular batch. And most importantly, over here, we have launched this Unacademy Pro. The link is in the description below, and click on to that link. And we have this Unacademy Pro. When it comes to the Unacademy Pro, we have got the Plus subscription, we have got Iconic subscription, and we have got Pro subscription, okay? Yes, there are some topics left that we will cover in the next class, okay? So we have the position time graph, velocity time graph, and acceleration time graph. Now only graphical part is there, and we'll cover that in the next class. And motion under gravity, all of those we'll cover in the next class, okay? So chill, don't worry, I'll finish all of this. That is my responsibility, my job, okay? So guys, there are a lot of students who want to learn online, but they want to give the test series offline. There are a lot of students who want to learn online, they want to basically solve the doubts in the offline center. So for that, we have launched this Pro subscription. So join this Pro subscription to avail these benefits, okay? So the link is in the description below. So, and you can compare Plus, Iconic, and we say Pro in this particular slide, okay? So thank you so much, guys. That's all for today. See you guys in the next class. Till then, bye-bye and take care. Thank you so much.